talked about angle-angle similarity. Today we're going to get into side-side-side and side-angle-side similarity. Let's start with side-side-side similarity. Side-side-side similarity works pretty well. It's proving two triangles are similar using only the sides. But unlike side-side-side congruence, where the corresponding sides are congruent, and angle-angle similarity, where the corresponding sides are corresponding angles are congruent, in side-side-side similarity, the corresponding sides are proportional. Now, there's all sorts of complicated ways of going about this, but the simplest way of doing this is to work with what's called the scale factor of the triangle, and to find the corresponding sides and reduce those fractions and see if they all reduce to the same thing. You'll find that it's actually a pretty straightforward process. So the question I'm asking here is, are any of the corresponding triangles here, are any of these triangles similar to one another? The way we find out is we line up the corresponding sides. Shortest to shortest, middle to middle, longest to longest. Now, fortunately for us, these are already color-coded, so I can tell what's the shortest side. So we'll start with A, B, C, and D, E, F. So the shortest side of AB is 8. The shortest side of D, E, F is 6. That fraction reduces to 4 to 3. The middle sides are 12 and 9. So 12 over 9. And 3 goes into both of those, and that reduces to 4 over 3. The longest sides are 12 and 16. And 4 goes into both of those. I'm sorry. Should go 16 over 12. I got to do it in the same order. My bad. Okay. Always got to go in order, larger to smaller or smaller to larger, whatever I establish as my order. Since I established larger to smaller here, I got to stick with larger to smaller. 16 over 12, 4 goes into both of those, and that's 4 to 3. They all reduce to the same thing. They all reduce to 4 to 3. So the scale factor is 4 to 3. Or if you want to write it as a fraction, 4 to 3. Since they all reduce to exactly the same fraction, those two triangles are similar, and we'd write triangle ABC is similar to triangle. Now we got to go corresponding order. A is the angle between the shortest side and the longest side. That's D here. B is between the shortest side and the middle side. So between the shortest side and the middle side is E. So D, E, F is my correct order. Corresponding sides, all set up, all reduced to the same fraction, which is the scale factor, and we're good. Next, let's see if D, E, F, and J, H, G are similar. So again, we'll set up shortest side to shortest side. That's 6 over 8, which reduces to 3 over 4. Middle side to middle side. The middle side here is 9. Middle side here is 10. Oh, that doesn't reduce to 3 to 4. So I can say that not similar. Okay, so D, E, F, and J, H, G are not similar. Now, little question for you. Since A, B, C, and D, E, F are similar, but D, E, F is not similar to J, H, G, could A, B, C be similar to J, H, G? Okay, and the answer is no. Okay, since these two, 1 and 2 here, are similar, and 2 is not similar to 3 here, that means 1 can also not be similar to 3. So we've compared triangles and we found that they're similar. We can also use this backwards, and this is really more like what we've done before. Find the value of x that makes them similar. Now we're going to have to set up and solve a proportion to do this. Notice I know what the short sides are. The short sides are 4 and 12. So 4 over 12 has to equal, or reduces to 1/3. So these other ratios also have to equal 1/3. So I could do it a couple different ways. I could say that the medium side of the medium side has to reduce to 1/3, and then cross multiply and solve. So 3x minus 3 equals 18. We add 3 to each side, and I get 3x equals 21, divide by 3, and x equals 7. And we've solved for x. Now I should check that to make sure it works. So if x equals 7, this is 3 times 8, or 24. And 8 over 24 indeed reduces to 1 over 3. We are good to go. So I substituted that 7 back into the other side that I didn't know, just to confirm it. And yes, it does reduce to the same thing. The scale factor between these triangles is 1 to 3, smaller to larger. Pretty simple stuff. Are there any similar triangles in this picture? Notice this time they're not color-coded, so we have a little more work to do. So let's start with LMN and RST. Again, the way we compare it, short side to short side. So the short side of LMN is 20, the short side of RST is 24. So 20 over 24, 4 goes into both of those, that's 5 over 6. Next, medium side to medium side, 24 over 30. Okay, that's 12 over 50, 6 goes into both of those, so that's 4 over 5. Oh dear, that's not the same, is it? 24 over 30 doesn't reduce to the same thing. So I know that these two triangles are not similar. All right, so let's move on. Let's see if RST and XYZ are similar, these two. So again, I'm going to take short side to short side, 24 over 30. 6 goes into both of those, that's 4 out of 5. Medium side to medium side, that's 36 and 30. So shorter one first, 30 over 36. 6 goes into both of those, that's 5 over, oh dear. No. Not reducing to the same thing, not similar. All right. So we're out of luck on that one. So how about the first and the third? Let's look at these two. Short side to short side, 20 over 30. That clearly reduces to 2/3. Middle side to middle side would be 24 over 36. 12 goes into both of those, that's 2/3. Uh-oh, looking good. Long side to long side is 26 over 39, which reduces to, 13 goes into both of those, which reduces to 2/3. Aha, those two are similar. So, triangle, and I can name this in any order, I'll go LMN, is similar to triangle, must be in corresponding order. L connects the short side and the long side. Connecting the short side and the long side here is Z. I'm sorry, Y. The long side is 39. So Y and M, angle M here connects the short side and the middle side. Connecting the short side and the middle side is Z, and then X. So there's my similarity statement. All right, your first question of the day is, I have a triangle similar to RST. The shortest side is 12. So I'm going to just draw that quickly. The shortest side is 12. That's the shortest side. Here's the middle side. Here's the long side. Find the lengths of those other two sides in order for those to be, that to be a similar triangle. You're going to have to set up and solve proportions. All right, so there's your first question of the day. Side similarity works pretty much the same. Basically, all you have to do is show the corresponding sides are proportional and the corresponding angle, which is between the two sides, has to be congruent. So, the way this works is pretty simple. Are these two triangles similar? I'm making a lean-to, are the triangles similar? Well, clearly we have the corresponding 53-degree angles. Those are congruent. Corresponding angles must be congruent. We set up a proportion of 6 over 9. What does that reduce to? That reduces to 2 over 3. 10 over 15 reduces to 2 over 3. They reduce to the same factor, which is the scale factor. Therefore, the triangles are similar by side angle side similarity. Pretty straightforward. Next, you get to try one. Are these triangles similar according to side angle side similarity? It's going to be a yes or no, pretty quick. Finally, number 4 here, we get to deal with, are there similar triangles here? Now, this is a tricky one because I've got 3 triangles in this picture. So what you're going to want to do is reorient them all the same way. So we're going to draw them all the same way, short side, middle side, long side. We've got a right angle here. Short side, middle side, long side for the middle triangle, short side, middle side, long side for the big triangle. Actually, I don't know if this is the right triangle, but I think it's going to be. And I start laying it out. Okay, the short side in the small triangle is 9. The middle side is 12. The long side is 15. In the second triangle over here on the right, the short side is 12. The middle side is 16, and the long side is 20. And in the big outer triangle, the short side is 15, the middle side is 20, and the long side, we're going to have to add the 16 and 9 together to give me a 25. This is a picture we're going to see a lot in the future. So it's one you're going to want to get used to. And if you set up your proportions, and I'll leave that to you to work on in your notes, you'll find, I think, that these are similar triangles. It's a pretty neat setup. All right, that's all for today. We'll see you in class.